So this is the third and last model of acids and bases, and this is for high levels. And so it's the Lewis acids and bases. And the reason we're doing that is to cover the last remaining rare sort of chemicals. They're acting like acids and bases, but they're not doing what Arrhenius says, which is acids give off H plus, bases give off H minuses. And then one of the most common bases we use doesn't do that, which is ammonia, because it accepts a H plus. So we've called it a proton donor, proton acceptor. And then we find a few more acids and bases that don't do that either. And so what they're doing is just accepting or donating electron pairs. And so if you're confused about how it works, just go to like a common acid and base. So if I just skip down to the water is the easiest one because you're most familiar with it. And so if you know that the H plus goes on to here, you can see that is absorbing a H plus. That must be acting as the base. So that must be the electron pair. It's donating the electron pair, which is a nucleophile because it likes the plus. And we always draw the arrow from the electrons to the positive ones, even if that was probably likely going in the opposite direction, because electrons are the smallest ones, so they're likely the ones to move in electricity, if you remember conventional current or real current. And so this one's doing the opposite, right? So it is acting as the Lewis acid electron pair acceptor and electrophile. The pulse likes the electrons. So just go to, if you're confused, just go to a common acid base that you do understand and look out whether the acid is giving or donating electrons and whether the base is giving or donating electrons. You might not even get a question on it. So always understand and don't memorize. And so it's as you probably know already, it's a coordination bond or a dative bond or a coordination dative bond or any combination of those. So here we go, back to this again. So a Lewis acid is a substance that accepts an electron pair. So an electron pair is coming from something here. Obviously OH minus is a good option. Acid neutralizing a base. And it's an electrophile, so it likes electrons. So the base is the opposite. So the base, this hopefully is a well-known base to you now. So that one is donating electron pair. So that's a nucleophile because it likes positives and it's negative. Okay, so coordination bonds, already took that before. This is the one that always pops up. I'm sure there's more. You can go research that if you like. Nothing's going on here. There's no protons popping off or joining on. There's no H pluses going off or H minus going off, which is Arrhenius. There's no protons coming off and joining up, which is Bronsted-Lowry. So this is just a pure Lewis acid and Lewis base with no overlap at all. So the Arrhenius and the Bronsted-Lowry have an overlap with that proton coming off thing. Okay, so lastly, this one's actually helpful for biology, to understand biology, because here we have an example of Lewis acids and bases. We've got no protons coming off or on. We've just got electron pairs with dative coordinate bonds, so the oxygen binding to the heme. Okay, so probably biology's got lots of good examples because that's a very good one.